So as we look into the next section, 12.3, involving uh, we have what's called measures of dispersion this time. So dispersion kind of like spray, disperse, spray out, uh, so things can kind of be close together or far apart. So dispersion itself means how spread out the numbers in the data set are. So we're actually going to give us a numerical value to describe how dispersed the data is. So if the data points are mostly close together, we call that a low dispersion. If the data points are really spread out, then we call that a high dispersion. And typically, we're really looking for patterns here. And dispersion, sometimes we don't see a pattern until we actually determine the actual value that goes with that. So that value kind of tells us whether or not we have a low dispersion or a high dispersion. So when it comes to dispersion or how far apart they are, if you will, some of the main words we'll come across is what's called range and standard deviation. Range is pretty simple, how far apart. A lot of times I think of age or weight, things like that. A lot of time for my own personal data is age and weight. I'm always to keep track of my brother and my sister were 4 years apart. So if I know my age, all I got to do is add four to my age, and that gives me my brother's age. And if I subtract four, that gives me my sister's age. And my sister has all kinds of ways to determine families' ages. She's got her own little patterns to figure out how far apart everybody is. So range is pretty quick and simple. So basically, this is it. Range, all we have to do is identify the maximum value, subtract the minimum value, and that's going to be the range of our numbers. So it's the distance between the smallest and the largest. But in subtraction though, you got to put the bigger number first, the small number second to get a positive value. Okay. So if I give you the numbers 4, 7, 10, 12, if I want to know the range, can we identify the maximum? Looks like 12 is the maximum value. And the min would be the 4. So 12 minus 4 would actually give us the range, which would be the 7. And that has nothing to do with the 7 that's actually in our data either. It's not connected at this point. So just the difference between the biggest number and the smallest number. So notice how the range is pretty basic. It's extremely easy to compute. And it gives us a kind of a spread here, how far apart the data is, because notice how every other number is between there. So our data range, and we have what, 4 points, range from 4 to 7. So we know our range numbers is 7. That's how far apart they are. That's how spread out they are, if you will. But it has limitations because it again is very sensitive to a number that's outside the norm, outliers, if you will. Also, it ignores everything between the min and the max. So we're really not paying attention to what kind of numbers we have between there. So it has its limitations, but it does tell us how far apart the smallest number is with respect to the largest number. So that does give us some important data here, but it does not pay attention to what's in between there. The next thing we get into is what's called standard deviation. More powerful, more informative way to measure what we call dispersion. So standard deviation is kind of a more complex concept, but trying to put it in some simple terms, this is about as simple as you can get. The standard deviation shows how far the data typically falls from the mean. So notice that the mean is very important to this problem. How far apart the data falls from the mean. So if there's a small standard deviation, so a lot of times we'll use SD for standard deviation. If there's a small standard deviation, that means the numbers do not fall too far from the mean. They're closely packed together with respect to the mean. A large standard deviation means they're really spread out from the mean. They're much further away from the mean. So this is the formula that we'll be using to determine what's called the sample mean. So S will stand for sample mean. I'm sorry. S will stand for sample standard deviation. So this little s stands for sample standard deviation. Notice how we have the square root symbol in here. Notice the whole thing is inside the square root symbol. So we got to do all the calculations inside the square root symbol before we actually can take the square root of it. And there's a lot of math here. There's subtraction, there's squaring, and there's summing. And there's division. A lot more involved formula. So yeah, we could do this by hand, but technology will allow us to not have to do all that data. Okay. So what's important about the standard deviation? Notice how it takes into account all the data, which where the range did not. So when it comes to dispersion, the range just focused on the first and last number, but the standard deviation really takes in all of them. So it works perfectly for this normal distribution. So we'll get more into that word later on, normal distribution. So uh, that gets into this dispersion stuff as well. And again, when we talk about a formal type of statistics, inferential statistics, the standard deviation becomes kind of very important. So if you see a lot of data on the television, there's usually this plus or minus number. That plus or minus is usually from the mean, which means that's really our standard deviation, if you will, how far we're from the mean. So it also keeps the same units as the original data. So units measure. So if we're talking about age, then it keeps the number in terms of age. If we're talking about money, it keeps the units in the term of money. So it's very, very important if whatever unit we're talking about, pounds, ounces, miles, all of that. The standard deviation is very powerful because it keeps that same unit as well. It does get affected by outliers, so sometimes those outliers are thrown out to help not just distort the data. But notice how it's going to be much harder to compute the sample standard deviation, if you will. So the range kind of does the total spread, but the standard deviation does the average spread around the mean. Notice how the range did not use all the data, but the standard deviation did. It's sensitive outliers. Both of them were pretty sensitive, but the range was more sensitive. Difficulty determining the range was a simple basic subtraction problem, but doing a standard deviation is much, much more complicated. So instead of doing it by hand, we'll probably lean more on technology. So it's common to advanced stats, range, not so much, but if I take you to higher statistical math, the standard deviation is kind of a norm to that. We use it quite often in advanced statistics. So this is going to bring us to an example in our homework. So I'm going to stop here and then we'll start fresh with a homework problem.